Hi, fourth graders. Welcome to Unit 2. Here we are, Lesson 1 on page 45 of your SAB. And today we're looking at how we can model multiplication. We're going to be doing a unit on multiplication. And you will notice right away that we're looking at an array. The number of unit squares in an array of connected unit squares is the area of the rectangle formed by the squares. We sometimes just show the measurement of length and width. This is something that you've seen before. You saw it in third grade, where we can say, oh yeah, we have 2 rows and 3 columns of stacked squares. Or putting them together, we see that our shape is 3 squares by 2 squares. Or even more simple, we have it just set up as a rectangle with measurements on either side, 3 centimeters by 2 centimeters. You can draw a rectangle for any multiplication. In the real world, we use multiplication for finding both sizes of arrays and areas of figures. So you can also think about this, of course, as 3 times 2 equals 6. There are 6 boxes inside this shape. And here we have that explained to us using the math dot board. They've connected the dots so that they're showing 3 by 2 and showing that 3 times 2 equals 6. Notice that when they are connecting the dots, they don't count the dots themselves, they count the space in between the dots. That's really important as we move into this unit. Just like if we were measuring something, we wouldn't count on the line, we would count that space in between the line. Okay, so this has directions for on your math board. We're just going to use scrap paper, and yes, I do want you to use scrap paper, or you can use your whiteboard. Sorry, you can also use your whiteboard for this. So draw a rectangle that is 3 by 2. How is the 3 by 2 rectangle similar to the 2 by 3? So, oh, I just see what they wanted us to do. 3 by 2. They're just showing us that we can flip it around like this. So 3 rows by 2 columns. And it's saying, how is it similar to the one we had here, and how is it different? So of course it's similar because it has the same amount of boxes inside, the same amount of squares. It's different because you are showing the 2 across the top and the 3 along the side. So really this is demonstrating the commutative property of multiplication, which states that 2 times 3 is going to have the same answer as 3 times 2. You don't have to write all that out in there, that's fine. How do the areas of the 2 by 3 and 3 by 2 rectangles compare? And here the answer is simply that they are the same. They are both 6. Again, you don't have to write out your answers to those two today. If we were in class, you would be doing that, but for now we'll move on because you've got online work as well. Okay, so for the next page, page 46, we're starting to look at those same arrays, those very simple arrays, but now they're getting a little more complicated because we're using larger numbers. So right away, this is looking like a lot going on, right? Let's zoom into just that first shape. There we go. So it says, this 2 by 30 rectangle contains 2 groups of 30 unit squares. So you can see that along the side, there's 1, 2. So it's a 2 over here. I'm going to write a 2 over there, but we know that that's 1 plus 1 equals 2. And then across horizontally here, how many columns do we have? We have 30, right? If you could count the space in between all those dots, 1, 2, 3, and keep going, you would get up to 30. So 30 by 2. And then what they've done is they've divided that into each row and shown 1 times 30 equals 30, because in one row, and then another row of 30, 1 times 30 equals 30, and then you have 2 30s. So what do you think the answer to this multiplication problem is if we have 30 times 2? 2 30s, or 30 plus 30, would equal 60. Now they're breaking it down a little bit differently. So in this picture, it's the same problem. It's the same multiplication problem, But instead, they're breaking it down into 30 across the top and 2 along the side. Notice that they've divided 30 into chunks of 10. We do that a lot in math, don't we? So we have chunks of 10. How many chunks of 10 would you need to get up to 30? 1, 2, 3 chunks. Good. Okay, so then down here, instead of dividing it in half, we're just letting that 2 stay there. So we don't have 2 ones. Instead, we just have a 2. So if you had 10 across and 2 down, your multiplication problem is 2 times 10, which equals 20. And then, of course, you have another one. 2 times 10 equals 20. And a third, 2 times 10 equals 20. If you add it up, 1, 2, 3 20s, what would you get? 60. So 2 different ways of showing how we're going to be working with these numbers. It's actually building up to one way that you're going to be using a lot. So right now we're just observing different ways of showing this in a model. Okay, so this is again a 2 by 30 rectangle. Instead of just containing 3 groups though, they went even further. Now they've divided into 6 groups. So check it out. We're back to 1 and 1 over here, and that's because we have this line drawn in the middle. We have 10, 10, 10, same as the last time. Notice they've got those plus signs in there. That's important because it's showing that 30 equals 10 plus 10 plus 10. Okay, and then because it's so divided up, each of these little sections is 1 by 10. 1 times 10 equals 10, etc. So if you're looking at all of those 10s and you add them up, what would you get? 60 again. Imagine that. So all those different ways that you are showing 60. Now here we have it numerically. So that means that instead of showing a model, we're going to be showing the math behind it. So this is the math problem we've been looking at. Go ahead and circle that because we should just look at that for a second. 2 times 30. There's nothing complicated about that. If we would cover up all this confusing stuff on this side, all we would have is 2 times 30 and we could solve the problem. What they're doing here is they are taking apart the numbers. They're kind of ungrouping them, you guys, so that we can show it in a different way. We can show it with an equation because in 4th grade, that's what we're working on. This is something called the distributive property. But really all you need to think about is how can we break apart that 2-digit number right there. So we have a 30. Look at this. The 2 here is going to take it 2 times the number in the tens place and then 2 times the number in the ones place. No, that's not how they're doing this one. I apologize. That's later. This one's actually easier. I'm sorry, 4th graders. Here they're just showing what multiplication problem you'd have to use to get to 2. So for example, to get to 2 here, we just do 2 times 1 equals 2. And then to get to 30, we would do what times 10 to get to 30? And that would be 3. Sorry about jumping ahead there. So 2 times 1 and 3 times 10. This is actually demonstrating the place value that you have to multiply just by 1 if you're getting to a number that has just 1 digit in it, then multiplying by 10 or a number in the tens place to get to the larger number. Now we've got this extra stuff down here. So what this is doing, it looks way trickier than it is. It's just rearranging these numbers. So do you see the 1 and the 10 over here? They've already used those. We have to use all 4 of these numbers down here. So they've already used the 1 and the 10. I'm going to cross them out from up there. It's kind of like a word bank or a number bank, right? So 1 times 10 is taken. Now what 2 numbers are left that need to go here and here? 2 and 3. The reason they're having you do this is they want to demonstrate again that when we're doing multiplication, we can flip the order of the numbers around, and in that way, we can have the same answer. This, I know I said it was the distributive property. It's actually the associative property here because they're just changing the order around. Again, not a huge deal if you don't remember that big fancy word. Just noticing, oh, okay, I can say 2 times 1 times 3 times 10, or I can say 2 times 3 times 1 times 10. Either way, if I multiply it out, I'm going to get the same answer. Okay, now down here, again, just kind of working backwards, what times 10 would equal 60? They get this 10 from the 1 times 10 here. What number times 10 is going to equal 60? A 6, right? And they get that 6 from the 2 times 3 here. So hopefully you can kind of see how those numbers work together. We'll continue practicing these. They do get a little bit tricky. Please go back to this part of your book if you're confused on your math expressions assignment today, because they'll probably give you one like this. And you can kind of play with it, see how it goes, but use your book to help you. Okay, on your math board, draw a 30 by 2 rectangle and find its area. So again, we're using our math boards or our scrap paper. You should have 2 here. Go ahead and write 2 there. And write 30 here. And then you want to do 30 equals... Just kind of practice drawing the exact same thing you see in your math, because that's what you're going to have to do in the next lessons. I know it seems like a lot of extra drawing, especially for a problem that we definitely already have the answer for, but the skill you are practicing here is modeling. You need to know how to create a model of 30 times 2. And then you could fill in the little multiplication problems here. So the 2 is actually going to be 1 plus 1, isn't it? So 1 plus 1. And then we have 1 times 10 equals 10. And you could fill that all in. How is the 30 by 2 rectangle similar to the 2 by 30 rectangle? Oh, again, they meant for us to do it on the side like this. So you're just demonstrating that even though it's in a different direction, in a different position, the answer is the same, and it still has the 30 times the 2. All right, 4th graders, let me know if you need any help. Good luck on today's lesson.